here we go. The first thing that I see is that we have a division. So I can change this, and I'm going to take the logarithm of both sides. So I'm going to take the logarithm of y. And then, since I have a over b, what would I do with these logarithms? Subtract them. So I'll get the logarithm of sine x times, now, whenever you see the cosine, and then you have a 4 there of x, that's like saying the cosine of x to the 4th power, which might be a nicer way of looking at it when you're dealing with this. And then you got your secant x minus the natural log of x to the 1/3. So that's our first step, taking the natural log of both sides, but since I have that division sign, I'm using that third property right there. Now, keep on expanding out the natural logs here. Since I have 3 multiplications here, what do? Add or subtract them? Add. So I'm getting natural log of y is the natural log of the sine of x plus, with the power, what do I do with the power? Put it out front in front of the natural log. And then I get the natural log of the cosine of x plus, I have a secant here, the natural log of the secant of x minus the natural log, well, can I take that 1/3 and put it out front? Well, that you better. Well, if you don't do that, the chain rule will actually take care of it. Believe it or not, if you forget to put the 4 out front, the chain rule will take care of it. So now, chain rule's monster. It's a beast. Now, with all of this, is there anything else that we have to expand using logarithms? No. So I can get into the differentiation, right? Now, one thing you got to stick in your craw and keep it there. Natural log of y is always going to be y prime over y, because it ends up being like the logarithm of u. The derivative of that is u prime over u. Now, remember, this is a way of making, we could use a quotient rule here, but you'd have a quotient of 3 products, and then your brain will explode trying to do this. So this is trying to make it easier on you. Now, what's the derivative of natural log of sine? 1 over sine of x. Now I have to multiply by chain rule because it's not x, right? What's the derivative of sine? Cosine. So it's going to be times, and I'll put it up top, times the cosine x. Plus 4 times 1 over the cosine x, which is nice because, remember, natural logs, the derivative is super nice for us. It's just 1 over. But what's the derivative of cosine? Alright, so negative sine x plus secant. So I get 1 over the secant of x times, I need the derivative of the secant, which is what? Secant x tangent x. Now minus 1/3 times 1 over x. Whew. That one's nice. Now we're in cleanup mode. So we've taken the derivative. We're in cleanup mode. I'm still going to have my y prime over y because I'm not going to multiply by y yet until I clean up the right-hand side. Cosine over sine is cotangent x. Sine over cosine is what? Tangent? So I'm going to get there's a negative and a 4, so minus 4 times the tangent of x. And then secants divide out, right? So this is just plus a tangent of x minus 1 over 3x. I'm not going to do everything at once. That was just the first step. So yeah. Alright, cotangent x. Negative 4 tangents of x. I got one more tangent of x. So 1 minus 4 is, so I have minus 3 times the tangent of x. Minus 1 over 3x. And now I'm going to take this, multiply it by y. But I know what my y is. So y prime, which is what I wanted to find, I know my y from the beginning is sine x cosine raised to the 4th power of x times the secant of x all over x to the 1/3 times the cotangent of x minus 3 times the tangent of x minus 1 over 3x. And if you wish to try to simplify this and waste about an hour of your life, rock on. But with logarithmic differentiation, this is where it usually stops. Do we got our y prime? This is what it ends up being. That's cosine to the 4th power. And I just didn't put it in the right spot, so I had to... My pen exploded, so there was an ink blot right there. Sorry. And so that was my y, and this is what I got from the differentiation there. So that works out pretty nice for us. Let's take a look. Smiley face. Worked out good for us.